Hello, my name's Yang. I'm recording this video as part of my interview application package for CodePlatoon 2020 August cohort. So to answer the first question, how did I learn something new and how would I do it differently if I had a chance and what was my approach? So I'd take my experience of learning code as an example since it's the most relevant. I started learning coding after college while still in serving the army. The reason is because I started realizing that all those big tech companies start changing the world. Software engineers started doing a great job. I just want to be a part of that exciting community. So I'm a doer myself. So when I decided to do something, I just literally started from scratch. I started googling the coding tutorials, and the first course I found was Intro to JavaScript from Udacity, and also along with that, there's also a lot of other intro courses from Udacity as well. I learned how to use Git and GitHub from Udacity. So very excellent courses from there. And also I bookmarked a lot of coding challenge websites such as LeetCode, Code Wars, HackerRank. So doing those really boosts my confidence and also kind of keep my skills up to date, so I can learn something and use it right away. So that helps me memorize all the what's called just not memorize, just get familiar with coding, get my hands warm. How I would do it differently is that I wouldn't do the learning what's called procedure very differently because I believe that was pretty efficient for me. I did search good websites to learn, such as like Udacity, Udemy, and also there's this website called Free Code Camp. So those are great resources. I would keep using them. But one thing I would do differently is that I would attend more meetups in person with other people who are also share the same interest in coding. Because I believe the benefits of doing that is you always have people to motivate you. Because coding can be dry, it can drain your energy, and also have somebody out there you can talk to and ask questions from. If he or she knows the questions you ask, it can save you a lot of time because a lot of times the things we don't know are just for beginners. They might not be very good explanations online. So if somebody knows, they can explain it to you right away in person. That's great. So that's that. The second question is how did I become interested in programming? I'd say that I didn't know I would be that interested in coding when I was just starting to learn. But throughout the process, I developed my interest more intensely because I realized I found myself just kind of reach out to internet to find solutions. I type in questions such as like how does closure work in JavaScript, and what's the difference between let and var. How does callback function works? How does the keyword that list changes in JavaScript? Those questions I try to um, find the solutions to on my own. So that's when I realized, oh, if I'm doing something like this, I'm actively looking out for solutions to my uncertainties. I know I'm interested in it, and also just doing a little projects and solving code challenges gave me a really a good sense of accomplishment and boost my confidence. So that's how I know that I am really interested in coding. And yeah, that's it. Thank you so much for listening. Hello, my name is Yang. I am recording this video as part of my interview uh, questions for CodePlatoon in 2020 May. So I decided to go over this questions from my code challenges, which is a medium question number 4. So here's the question statement. Given a function, write a function called add neighbors that takes an array of numbers and adds each number in the array to the number next to it. So what does it mean is that if we have a array of 6 numbers in it, we'll add the first 2 together, sum it up, and add the next 2 together, sum it up, and add the last 2 together, sum it up, and then we'll put this sums in a new array and then return it. Alright, and let's move on to the examples. So here's what I just explained. The first, for example, the first array of 1, 2, 3, 4, 5, 6 will return the result as 3, 7, 11. And the array of 12, 32, 35, 28, 10, 18, 55, 7, 8, 1 will return 44, 63, 28, 836, which is the sum of each corresponding group of 2 elements. So basically, the logic behind this is pretty simple. We'll grab the first 2 numbers and sum them up, and we'll leave the remaining elements aside, and then we'll do more with them later. So you get 3. That's going to be put into the returned result. So that's going to be 3 is going to be the first element. And the remaining element numbers are 3, 4, 5, 6, and you just do this repeatedly. You get 7 as the sum of next 2 array numbers, and you get 11 as the sum of the last 2 elements. So eventually 3, 7, 11, you put them all together is what the solution should be. So as you can say that this can be done easily using a iterative method, which is like a for loop or a while loop that go through all the numbers in the array. But also when you see something like this where you write code where you just iterate through a array, that's also a good signal where you can apply recursion. So what is recursion? So basically, recursion is that you will divide this problem into smaller subproblems, which are then solved recursively until such time as they are small enough and meet some base case. Okay, the keywords here are base case and recursively. So what is base case? Base case is basically the case you define in this recursive function. So when this base case is met, that will terminate the recursion. You will return a value. The recursive case is that will happen when a base case is not met. We'll recursively call the function within the defined function again over and over until the base case is met. We'll talk more about it in my code I will write in a bit. And this is the essence of recursion. So if the base case is not met, the function's recursive calls will call the function again with modified values. So what is modified values? We'll explain more about it in my code later. So basically, when you call the function within a function again, each time the argument you put in that function is going to be modified. The code must be structured in a way that the base case is reachable after some numbers of iterations, meaning that each subsequent modified value should bring you closer and closer to the base case. Okay, this is very important because, like I said, when you call the function recursively within another function, the argument is not going to be the original argument you put in. It's going to be modified. And each recursive call modifies the values in a way that you will get closer to the base case. So once the base case is met, the solutions for each subproblems are combined and the result is the answer to the entire problem. And that makes sense, and I will talk more about it in my code, like I said. So put just like a recap of what I just said. To solve a problem recursively, we need to define a base case. Also, we need to test in the function if the base case is met or not. We should check that. And from there, we'll give two scenarios. If the base case is met, then we'll return the solutions. If not, we'll call the function itself again with a modified argument until the base case is met. All right, and here this is not a recursion. All right, I will write a code to illustrate what that means. So basically, the examples here is this. So eventually, this should log out 3, 7, 7, and 11. All right. So we'll say function add neighbors. We'll say we're putting an array in there. So what did we say earlier? We need to define a base case. So what is a base case? Think about it. Just pause a second, think about it. So now we have an array of 6 elements in there. And each time we're grabbing 2 elements, 2 elements, and 2 elements. And so remember when we talk about this graph right here, we're always separated into 2 parts, the first elements and the remaining elements. But as we go deeper, we do the same thing for the remaining elements. Each time the elements get shorter and shorter. Eventually, the last steps where we stop is happens when the array only has 2 elements left in there. So that's our base case. So basically, we need to structure this function in a way that the input array is getting shorter and shorter, and eventually you will reach the state where it only has 2 numbers in it. So we'll say if array.length equals 2 in this case, then we'll return array 0 plus array.1. That's the first array's first element and the second element. But then we'll put them in a array form. So it's like one array containing 1 element. And we'll all say if this base case is not met, what's gonna happen? If it's not met, like we said, we'll treat this. So for example, the starting array is 1 through 6. So obviously this code is not gonna run because array length is not equal to 2. So what happens next? We'll do a separation of the array into the 2 parts, which is the first 2 elements and the remaining elements. So we'll say the first 2 is equal to array.slice from 0 and to index 1, and the remaining one would be array.slice starting from 2 all the way to the end. Okay, so this is important here. This is gonna be 1 and 2. This is gonna return us, think about it, it's gonna be 3, 4, 5, and 6. And now if we go back to our PowerPoint, I was saying that we need to, in order to do recursion, each time, the important note about recursion is that we call the function within the functions. So somehow we need to call this function again, but with a modified input. And the modified input should bring us closer to the base case. So as you can see, this is our modified input, this one right here. That's the remaining elements after we take out the first 2. And as you can see, this has a length of 4. It's already shorter than the length of 6, right? So it's getting closer to the base case, which is right here 2. So we're getting there, one step closer. So what we're gonna do is that we will call this, call add neighbors again, but this time we'll put remaining as our input for the recursive step. And as you can see, once we call this function goes, it will come back to line 1 again. All right, it will check. This time the ARR is going to be remaining. So that's going to turns out to be length of that is going to be 4. Okay, still the base case is not met. All right, and then it will run to this line. And then in this case, just possibility to think about it, what's going to be. So your input is remaining, and you're still doing the slice, first 2 elements. So this time it's going to be 3 and 4, right? And then the remaining of that is going to be 5 and 6. And then you come back to this step again. All right, and then this time the remaining is going to be 5 and 6. When you put 5 and 6 as remaining and call add neighbors on it, it will going to run back to line 1 again. And this time the length is going to be 2, and this condition is met, and then we'll finally return. We're not going to come back to line 2, line 3, line 4 anymore. We return already, and what the return value of that is going to come back to this function. This function is going to be returned as 5 and 6, the sum of 5 and 6. Actually, that's going to return us to 11. Okay, we're getting very closer to okay, it's kind of getting closer to a solution already. But now we know that eventually we want to get a 3, 7, and 11. Now we have 11. What happens to all the previous sums? What happened to 3 and 7? Where did it go? So 3 actually comes from the first time we call this function. The first 2 is going to be 1 and 2. Its sum is going to be 3. 7 is going to come out from the first time when we call the recursion function, when the remaining was 3, 4, 5, and 6. And the last 2 elements is going to come out to be 11. So when we do that, we need to put them all together, right? Put them all together. So what do we do is that first 2 is going to be this number. Okay, first 2, we'll add them together, right? That's going to be our array. Sum of first 2 elements is going to be 3. And we'll add the remaining elements all together. Because that comes back from the recursive call. And then we'll return this. Okay, let's see if this goes well. Alright. First 2. Dot concat. It's not a function. Okay. Oh, okay. You know what? Not concat. Concat. Okay. Sometimes I make stupid mistakes. All right. There you go. So basically, we got the solution 3, 7, 11 when we call this the logs out 3, 7, 11 to the console. So basically, the gist behind it is that when we use recursion, we always call the function itself inside the function. And also, an important note to notice is that each time the argument put into this function is modified each step. Because if we don't think about it, it's going to be infinite loop, because if you don't modify it, it's going to just run over this line over and over again through 1 to line 4. We need to change this input array in a way that it's getting closer and closer to the base case. Base case here is actually testing if the input array's length is 2. And as we can see, the remaining one is getting shorter and shorter. So eventually it will reach the base case of 2 and then return. So once that's returned, the recursive call is gonna loop back to the original first call right here. And then that is when we return the whole combined solution. So basically, a key points to remember is that when we use recursion, we always need to design a good base case and a good recursive case. And also we need to modify the value in a way that the input for the recursive call is getting closer and closer to the base case.